What's up, everybody? Sparrow with a Gun here from Sleepless Studios, and this is my first episode on a brand new series on Space Engineers programming using the programmable block that has been implemented in the game. Now, the block's been implemented for a while, but I haven't really taken the time to really derp around with it, and in my last episode on my survival playthrough, I did a little script that would show the inventory of a cargo crate, and everybody seemed to really like it, and was, and when I mentioned maybe doing a series on kind of tutorial on it, everybody really seemed to gravitate towards that. So this is the first episode. Granted, it's kind of a tutorial, but it is not like a class or anything. I don't have like a plan, oh, by this episode you'll have known how to do this. That's not how it works. Pretty much I'm just going to go through the basics of how everything works in this episode, and then we'll start on doing different little project things that you can kind of follow along and see how it's done, kind of thing. Things like the script for showing how to do inventory of a cargo crate, how to pick out certain inventories, how to, for example, then take that, and then maybe in another episode we'll end up doing like a whole ship's inventory system, things like that. It's going to be like more project-based, like functional things we want to accomplish. Then, this is the key concepts that we're going to go over. So, before we do any of that kind of stuff, though, kind of need to go over the basics. Now, granted, this I did not do through programming, just FYI. I thought about it, but I just kind of wanted to get into this. So this is just in the LCD panel. It's just in the public text, and I moved it around until it looked kind of centered. That's all. So the first part that I'm going to be doing here is, obviously you need a programmable block. And it has a couple functions you can edit, and then this is where you edit your code. Check code is essentially like compiling for anybody who is familiar with programming. You have to compile the code before you can actually run it. So check code, when it says successful, means now you can run it. Remember is like saving. Remember and exit means you exit but it saves, and then run will actually execute whatever script you wrote. So first off, I'm not going to do a whole programming course thing on the language. I'm just going to do a brief overview for anybody that is new to programming, but I'm not really focused on teaching you C#, which is what the programmable block uses, is C# coding. So we're just going to go over some basic key concepts that, if you're not aware of how it works, you need to be aware of it for it to make sense. Now, granted, there's a lot of tutorials on C# and stuff online, so I'm not worried about giving you a real thorough explanation. But, so we have a function here called and you can see that it has a void main. So basically the syntax is what we're going to be going over here for a minute. So what this is a function is identified by, now I will say one thing before I get into this. Even though I have studied programming, I am very, very bad about remembering the difference between a method and a function. They're very similar, but I don't remember exactly what makes them different. So if I use the two terms interchangeably, that's my bad. But they kind of do relatively the same thing with a few minor details that I always get them mixed up as to which one is which. So for those of you that are familiar with programming, you don't have to bring that up as far as like, oh, this is, you got that mixed up. I probably will get that mixed up a lot, but I normally use more references to functions than methods. But so, the way you can identify this is through a return type, which in this case is void. This means it won't return anything. It won't give the line that called it anything back. And then main is what identifies this is the main function. That's like, it's just like the title. The parentheses are for arguments. If there's nothing in the parentheses, it doesn't take an argument, so you can just run it. And an argument is essentially a piece of data that it needs to execute the code inside it. And then you have the curly braces is basically the beginning and end. So you have an open to the right and then a close to the left, and that basically identifies that there is something in between here that runs whenever main is called. So for example, just something so before I get into that, let's go over the basics of variables. And what a variable is, for anybody, again, this is all very, very rudimentary programming stuff. It's not for people that are familiar with it already. But a variable is basically just something that holds data. And the data type is what determines what kind of data. So the main basic ones, and I'll probably forget a few of them that are less common, but the ones that you use a lot are integers, doubles, floats, string, though string is a little bit tricky as far as how it's identified. Some it's str, some it's string. So that's one of those that you have to know the language. I'm fairly certain that in C# it's identified as string. Character is basically a single letter or symbol. And let's see, is there any other ones that you use frequently? I think those are the most frequently used, strings, integers, floats. And in C# there's one called a var, or variable. And essentially that just means that we're not really sure what's going to be in this, so you could pick from any kind of variable, including ones that aren't listed in this little list that I've done. A var is just saying that this is a variable, and then C# is kind of like going to figure out what kind of data type it is based on what information you put into the var. Is kind of how vars work. So it's good for things where you're not entirely sure what is going to be filling in, like returning from a function, for example. If a function returns string, but and that's something I should show. I showed a void of when they don't return, but say I wanted it to return an integer, it would be integer main, like that, and then that shows that whatever happens in this function, it's going to give you back a number, so you would need to store it in something. Voids you don't have to store in anything because they don't return anything, but return types do. And then you have to basically assign any of these, you would need to give them a name, much like a function. So let's actually run through with a test, for example. Let's see, what could we do? It's difficult on this programming block because there is no just like straight monitor type thing. And I didn't really want to get into the more advanced part of this yet. So let's just keep working with this. But so say I want to make an integer called amount, like it's going to hold the amount of something. Then you would define it like this, and almost every line in C# will be closed with a semicolon. That closes the line to where the compiler in the code will see, okay, this is how this is the end of this line, let me move to the next line. The exceptions would be things like a function. You don't have to put a semicolon down here or a semicolon up here, anything like that. But if it's not a function and it's just a line of code, you would need to close it with a semicolon. So this defines an integer titled amount, but there's nothing in it. It's not been what we call instantiated. Instantiated is basically where you put something in there. So there's now an instance of that variable. At the moment, it's just a placeholder that has nothing in it, so it's not actually using data. And there are two ways to do that. You can declare it like this, and then you can add to it later, like saying amount equals 0 would now instantiate it at 0. So there's a number, an integer of 0 stored in the amount. Or if it's going to be a blank value like that where you're just making sure that it's got something in it, you can put it right in the declaration line. And then down here, you could put, say, 10. And now what's going to happen is the next line, when you check for what amount is, it's going to see 10 instead of 0 because this is just the default value, and now you've actually assigned it something. So the equal sign assigns things. That's very important if you're not familiar with programming. Equal assigns things from the right side to the left side. So whatever's on the right is going to go into the variable on the left if it's an equal. If you're actually wanting to check to see if something is equal to something, you use two equal signs, but this is not the correct syntax. It would be if amount equals 0 and then curly braces. So this basically, an if statement works similar to a method or a function, in that you put if and then the argument. We talked about arguments briefly with the functions. An argument is like this. It's a piece of data that it uses to complete something. Now, in an if statement is just going to leave it up here, and it's going to check if amount is equal to 0. A main method would actually have it inside here. So that kind of gives you a basic understanding of what's going on. And feel free, I don't really want to get any more in-depth into that kind of stuff because I could just talk for hours on how the syntax works, and that's not really what this video series is for. So, what I would recommend is if you have questions, let me know in the comments or things like that, or Google C# tutorials. But I mean, that's kind of the basics of how to get you going so that you can kind of follow along with what I'm doing and things if you don't understand. But I highly recommend, if that's new to you and you're still learning that kind of stuff, then I highly recommend going through a C# kind of tutorial or course or whatever before getting into this stuff, because other than just specific people going, hey, I don't understand what this part of the code does, I probably am not going to get super in-depth on the C# side of it. I'm going to stick more with the programming side of this. Okay, so first of all, I want to hook up this LCD panel because LCD panels are really, really cool to work with, and it would actually give us a monitor to test our code and see what's going on and things of that nature. So to do that, we have to get into the actual API of Space Engineers, how it works. And the difficult part with this is there's really not a lot of good documentation on how everything really works, because basically, for again those of you that are just starting out with programming stuff and don't really understand exactly what I'm talking about, Space Engineers has its own language embedded into the game, essentially, that it uses C# as a basic coding syntax or language, but then it adds its own variables and things into there so that you're connecting to actual blocks and devices within the game. And because of that, you have to know the naming conventions and what they defined everything as, and that's where things get complicated because the documentation is kind of bare bones as far as it literally just lists on the wiki the different variable types. So for example, the LCD panel is a text panel, I believe. I think it's still seen as a text. And so because of that, I was actually looking on the wiki and I don't see the text panel listed on that one, so I think it's actually in a different area. That's what I mean, is the documentation for the API is kind of lacking. It isn't really what it could be. So you have to use, I'm trying to remember what I did on my survival world. I believe it's my text panel. And so this declares a variable of that type, and we're going to call it display, and then it's going to be this is another area where I'm still kind of getting my own feet wet. Actually, let me pause it for a second. I'm going to write up a code that works, and I'm going to test it, and then I'm going to actually come back and walk you through it instead of me actually doing it on the fly. Okay, so finally got it working. I ran into a bit of an issue where the programmable block's ownership was not set to me, but the panel was, and so it was not able to communicate with them. So that's important. It's very important. In fact, I'm going to go ahead and set all of this stuff to me, so that we don't run into that anymore. But you'll notice this says this is now our monitor. And the reasoning for that is the script that I wrote here. So what we've got is the IMyTextPanel display. So displays the name. This is the variable type defined by the API inside the game, which unfortunately they don't have an LCD panel display variable, so text panels and LCD panels are seen as the same objects. So keep that in mind if you're ever wanting to compare between the two. Now, this is where things get a little more dicey. The grid terminal system is a variable that's defined in the API that you don't see here. It's not something that you see an instance of, but you can call on it anyway. So the grid terminal system, what that does is it's basically anything that is connected to this programmable block. Any block that connects. So all of this. Now, if I were to make a new large ship and place it out there, I wouldn't be able to access it through the programmable block, at least not easily. But the grid terminal system refers to this. It's the whole. Think of this, how it's all snapped to a grid. So think of anything on this grid of a base as the grid terminal system. So every block within the terminal system can be accessed via this variable. But it doesn't. It's very complicated as far as it's not really a thing where that variable type doesn't give you access to all the properties and methods of each data type. So you have to pull from that. Think of it like a filing cabinet. The grid terminal system is basically a filing cabinet for this entire station. And then you get a specific block and give it to this variable of this block type. And then you can actually access it as if it were something, as if it were one of these, instead of a grid terminal system. So this here is IMyTextPanel inside two parentheses. What that is called casting, and it's basically telling the this line here that when you return this block or return this item, I want you to make it think that it's this, and this gets rid of issues with varying data types. For example, if I were to remove this, this is getting I kind of hadn't gotten to this part yet, but a dot can be used to access a method or a function or variable property, whatever, inside a data type. So grid terminal system dot get block with name is saying use the get block with name function inside the grid terminal system. So that's a kind of often used ability as well. And like we talked about with arguments, this get block with name needs a name argument, so that it knows what to look for, and then when it finds something that has this name, it returns it, and again, it's on the right side of the equal sign, so it gives it back to this variable. Now what you'll notice is I've taken off the cast to where it doesn't say I'm going to be returning a IMyTextPanel. And now when I run it, cannot implicitly convert type API in-game terminal block is a generic block. It's any kind of block on the grid. So it automatically returns a terminal block. Well, it can't convert it to a text panel. Hence why you tell it to convert it to a text panel with this casting right here. To where now when it returns, it goes, I'm giving you back a terminal block. Oh, wait, I'm giving you back a text panel. And then the text panel goes, oh, thank you. So now when you check it, it compiles successfully. So that's important when you're dealing with grid terminal systems and stuff, is to know what it's returning back. And if you get a conversion error, you may have to cast it or reconfigure your lines so that it knows how to do things. Now the quotes here identifies a string. We talked about strings earlier. This is a string as well. The write public text function of the text panel, which is display as the text panel. So we're accessing the write public text function within that data type, and then inside the parentheses we're giving it its 2 arguments. Now this one actually needs 2. It needs a string, which is this, and then you have a comma to separate your arguments, and then it has false, and I forget exactly what this is for, but I think the default argument is false, and then if you do true, it dictates something else. I forget though. And again, there is no IntelliSense or anything that tells you what functions or methods or arguments are needed in this editor. This is just like a straight text editor. So that's kind of one of those things that you would have to research or just fiddle around with it enough until you figured out what it does. I don't remember exactly what this is for, but by default I leave it as false. Because I don't really use it any other way. But you need both arguments for this function to operate correctly. So this string, this is now our monitor, think of a string variable as a character variable. We'll do it this way. A character variable. Actually, now that we have the panel hooked up, I can show you what I'm talking about. So we'll do a character called letter, and we'll assign it a why not, and then close that, and then we'll do a string called str, which is kind of the abbreviation for string, and then we'll do this is a string. Now if I were to put more than one letter in here, I'm gonna get an error. Cannot implicitly convert type string to character. And so I think that's from that line anyway. That actually is backwards from what I was expecting. Nope, it's actually from this one. Why is it from this one? This is, wait, no, line 5. No, it is from this one. Oh, I see. Let me see if this will fix it. There we go. Okay, so with a character you use single quotes. I forgot about that part. If you use double quotes, the compiler thinks you're trying to do a string. But this is the actual error I wanted. Too many characters in character literal. Okay, so what that means is you're trying to put a string of characters inside a character variable. But that's why this is defined as a string, is because it's more than one letter. So now here's another fun part. What we're going to do here to show that point is we're going to do letter, and then we're going to append another string thing, and this is a escape character called a new line character, and it basically is like breaking to where it'll go down to a new line, and then we're going to append. So this is all one string. We're just using a variables instead of the raw string code with in between 2 quotes, because these contain strings or characters. We're just putting them in as variables, and it will automatically read what's in the variable. So then we can do str, and we'll append another new line. And I apologize if I'm going really fast. It's just this is all very rudimentary stuff, so it's hard for me to kind of slow it down and do the basic stuff again. It's very difficult. Now, because a string is a string of characters, what you can do is you can actually use it as an array, and we haven't gotten really into arrays yet, but this is going to be kind of a crash course. So the array, an array is basically just that. This would actually be a good example of an array. So you use brackets to access an array by an index. So essentially the T is index 0. And an array can do from 0 to the end of the array, however many items you have in it. So for example, this one has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, it's a max index of 15. You have 16 elements in the array, starting at 0 to index 15. And each one of those index numbers will give you a different character. So for example, 0, 1, 2, 3 should give us an S. Oops, and I put in 4. So you put a bracket in here, and the number in the middle will identify what index within the array you want it to do. Okay, so let's remember and exit. We're going to run this. And for some reason, these panels don't like updating. So if you go in and change the show text on screen to something else and then go back to public, it'll show it. So as you can see, the first one is our character, the second one is our string, and then the third is accessing an actual index of the array that is the string, if that makes sense. I hope that makes sense. It's a lot of terminologies all at one time. But you can use this not only with strings, but you can also use it for other variables. For example, if I have 3 integers and I title them integer 1, let's equals 0, integer 2 equals, well, let's make this simple. That's going to get confusing. Okay, integer 3 equals 3. And now we can go in and have it display that right there. We'll do a new line. And let's just copy this text. And you can use Control-C and Control-V and for copy and paste and such. Integer 2, integer 3. Okay, compile that, should run. Now, we'll refresh this, and I may end up figuring out a way to set up a timer block to automatically refresh this kind of stuff, but that'll be something I do some other time. Alright, so you can see that it says 1, 2, 3. Now, so these are your various integers, but what we can do is type in an array of integers, which equals integer 1, integer 2, and integer 3. I believe this will work. I haven't done syntax identifier expect. Okay. Oh, I didn't put in a name. So we'll put in array. Cannot convert type to local variable name is already defined. Okay. So hold on a minute. Okay, so figured it out. I was getting the syntax mixed up with another language, so that was the problem. So to declare an array, you do the data type, 2 empty brackets, and the identifier, close it with a semicolon. Then you declare, or you assign, the array equals a new, and this is important, this is actually a C# keyword. You wouldn't want to define any kind of like variable or anything as new because it would conflict with the keyword of instantiating a new object. So you declare it as a new integer array with 3 elements and then close it with a semicolon. Now this is seen as an actual array with 3 slots. And then you can see what I was talking about with indexing before is array 0 equals integer 1, 1 equals 2, 2 equals 3. So you can see that there's 3 elements, but they start from 0, go to 2, instead of 1, 2, and 3, it's 0 through 2. Then I assigned string, we saw it up here, that this is equal to, this is a string. Well, I changed it. I added here, string equals 3 new lines, then array 0, break line, 1, new line, 2, etc. So that this holds all of our array values, right? Actually, for ease of use, let's show it with some different numbers. So let's do 7, 8, and 9 so that it'll be a little bit more clear. We'll recompile that. And I have this as the same that it was before. It has integer 1, new line 2, new line 3, and false. I looked up, I took the time to figure out what this was. It's actually an append value, much like this plus sign. So what I did here was I have another write public text function where we're writing string, which is this value, but I made this one true, so it's going to add it to this one because it's the append argument is not false, and so I'm telling it to append it to the rest of what already exists in the public text. So we're going to remember that. We're going to run it. And then we look over here, you can see we have 1, 2, 3, 7, 8, and 9. So that kind of gives you an idea of what arrays can really do, is they're used a lot to hold a lot of variables, and then you can just index them and access the individual index. So if you have a lot of the same variables, they work really well. But we are really running long. I did not mean for this episode to be that long, but it's just there's so much to go over the basics of things. So let me know what you guys think. If you're more interested in seeing more on this series, if you really want to get into more complicated stuff, let me know. I tried to kind of keep things somewhat basic and go over the basics of just programming and syntax in general for those of you that may not be familiar with programming at all. But if everyone's like, you know, yeah, we got this, let's move on to how to make the game do stuff, do let me know, because that would be a big weight off my shoulders of having to explain every little nitty-gritty thing. And we can get into some more advanced projects and things like that. So let me know what you guys think in the comments. In the meantime, I hope you all enjoyed. If you did, leave a like, and I will see you all next time. Peace.